So we know that when we do the indefinite integral, we have to always add c because it could be anything at the end. Now, in some situations, we can actually solve for that c. So for example, if we have dy dx is 2x and we integrate, we're going to get x squared plus c. But in order to find that c, we need another piece of information. So this is what the questions are going to look like when you're given that extra piece of information. And that extra piece of information is often in the form of a point. So we've got the function. We want to find the function f of x. We know that the derivative is 3x. So to find f of x, we're going to have to integrate. So we're going to add 1 to the exponent and divide that by that number. And we always say plus c. But now that we know that the curve passes through the point 2, 12, we know that when x is 2, y is 12. So just like you've done in a number of different situations in math before, you can plug those values in. And now the only thing we have left to solve for is c. We can simplify this. This will be 12 divided by 2 is 6. So we find out that 6 is equal to c. And now we can write out, because it said find the equation, now that we've solved for c, we can write out the equation is going to be 3x squared divided by 2 plus 6. So whenever we do the indefinite integral, whenever we work backwards, we always have to remember that we're going to have to add c. When they give us more information, we can solve for that value. So in this case, since we knew that the original equation went through 2, 12, we could plug that in and solve for that. Now this question is asking the same thing, just using words in a little bit different ways, so it's good to see how we can ask the same thing but sort of present it in a different way. Gradient is another word for slope. And so this is saying that the slope of a curve at any point, x comma y, is 16x cubed minus 3 over x to the 4. In other words, that tells us that we know that our derivative is 16x cubed minus, and I'm going to change that x to the 4 on the bottom to an x to the minus 4. And it tells us it passes through a certain point. So we're going to be able to do the same thing. We're going to be able to integrate. If this is our derivative, we can integrate, work backwards to find our actual function, add 1 to the exponent, and divide by that value. Add 1 to the exponent, and divide by that value. And then we have to remember that there'd be plus c. So now that we know it passes through the point 1, 4, we can plug in 4 for y. I'll simplify. 16 over 4 is 4. And negative 3 divided by negative 3 is positive 1. So now you can plug in 1 for x, 4 for y. And solve for c. Yes. Well, with this right here, right, and all 1 to the minus 3 is the same as 1 over 1 to the positive 3, right? That negative exponent rule. And so this will still be 1 over 1, which is 1. So yeah, remember that that negative exponent, you might want to change it back to a positive exponent here to help you think about it, but it will still be positive 1. So when we integrate, we always write plus c. Sometimes you're going to get questions like this next one, where you're starting from the second derivative. And you will go work backwards once and you'll have plus c, but then when you work backwards again, you're going to have a plus another letter. And since you've already used up c, you have to use another letter. So why not use the letter d because it's next? So this next one's going to have enough information for you to work backwards once and solve for c, and then work backwards again and solve for d. Ready? So I'm going to get you to try this one to start it on your own. We'll go over it in a bit. But try to see, right, we're starting with our second derivative, working backwards once will get us to our first derivative. And there's enough information there for you to plug in a point to solve for c, and then you work backwards again, and we'll solve for d. Keep going. So first of all, if we move from the second derivative up to the first derivative, add 1 to the exponent and divide, and plus c, this will be the equation of the first derivative. Now, in the question, it says that the gradient of the curve at point P is 23. And again, gradient is another word for slope, and slope is another thing that your derivative finds. Your derivative is the slope of all tangents at all points. So if we put in, well, if we make a statement here, we know that dy dx is equal to 23 when? Only at one specific point. And that point is when, right here at 213. In other words, we know that that slope is 23 when x is 2. Now that's important to write it out that way because that allows us to take this equation, plug those values in, and get that c is going to be equal to 3. So now we can rewrite, we know exactly what the derivative function is. We know that it's going to be, well, I'll simplify it to 6x squared minus 2x plus 3. And now working backwards again, we can integrate again. And since we use the letter c already in this question, we've got to choose a different variable because c and d do not have to be the same. And now we know that our original function passed through the point 2, 13. It was 13, right? So now when y is 13, when y is 13, x is equal to 2. And now we can solve for d. It's going to be 12, 18, move it over, and we get d is equal to -5. So when asked to find the original equation, we can do that because we solved that c value had to be 3 and the d value would have to be -5. So there'll always be information, if we go back to the original question, there'll always be information in that question to help you figure that out. I think the hard part here is to see this part right here when the slope is 23 happens when x is 2. Because it doesn't tell that to you directly. It kind of tells that to you indirectly in this question. It says the slope is at point P is 23, and then you have to know that you're going to need that x value of 2 from point P. But other than that, these questions are fairly straightforward, solving for c or solving for c and d, where you're going to take your indefinite integral, and then you're going to have a point that you can plug into there to find that value. So they're pretty straightforward.